Welcome back, my friends. Section 5.3. Today we are going to talk about one of the more important topics in linear functions, and that's the idea of slope and rate of change. Just be careful. I'm going to throw out a little danger, warning, that this is one of the more trickier concepts to understand in this chapter, so make sure as we go through this you write down any questions you may have as you go through the notes. So let's go ahead and start talking about slope and rate of change.
The summer wind came blowing in from across the sea. It lingered there to touch your hair and walk with me. All summer long we sang a song, and then we strolled that golden sand. Two sweethearts and the summer wind, like painted kites, those days and nights, they went flying by. The world was new beneath the blue umbrella sky.
All right, how many of you fell asleep during that? Whew. All right, here's the point. Why I did that to you guys on purpose is we're talking about slope and rate of change. So there you go, a little Sinatra for you, but here's the idea about slope and rate of change. And I want you to think about this idea of what's called rate of change. Rate of change, we're going to talk about when two things change in relation to another. So here's the idea that I want you to talk about. I'm going to show you this. I wanted to have you visualize it as a picture, but also to show you on a graph. So here we had Grandpa George. Okay, we have a good old Grandpa George. You know I'm not talking to one from Willy Wonka and the Chocolate Factory. But Grandpa George started from his house and walked over a long distance to this point here. So he walked this entire distance as you saw. So let's say where I were to represent this distance on this graph. So here I have a graph of distance in feet versus time in minutes. So you can see the time on the x-axis, the distance on the y-axis. And here I have marked 2 points. Okay, so if you think about what these 2 points mean, I have really 2 points that have two values. So think about a point always has a value of x and a value of y. So I have 2 points here. The first one you can look at is at a value of 4, 3. So that means that 4, 3 is one of my first points. And the second point that I have there is at a value of 9 and 7. Now, what do these points mean? Remember, if you look at the axes, time represents minutes, y represents feet. So when I look at this one, this represents 4 minutes and 3 feet, and 9 minutes and 7 feet. I want you to be able to visualize this on this picture, is that here, after 4 minutes, Grandpa George only traveled 3 feet from his house. So this right here represents that he traveled 3 feet from the house. And this took place after 4 minutes. Okay? After 9 minutes, it's shown that he is at 7 feet. Okay, so I'll put 7 feet right there. Now, no, it's not exact right there, but just showing you about what's happening. Okay? Now, a couple things here. First of all, if you look at the graph of what's going on, we have these 2 points. Notice that if we were to connect these 2 points, what we do is we have a line. And remember, this whole chapter is on linear functions. So between these 2 points, we have a line that would connect them that represents this situation of Grandpa George walking. Okay, now what we want to do is we want to find the slope or the rate of change of this line. You may have heard the term slope before. Slope, you probably think about maybe skiing or sledding or something like that, something that has some sort of angle to it, like a hill has a slope to it. Something that's flat like a floor doesn't have slope, and that's the same idea as rate of change. So we want to figure out what is the slope or the rate of change of this line. To do that, we're going to look at this problem. So what we know is 2 things. We know that Grandpa George went from 3 feet to 7 feet. So the distance he traveled changed. He didn't stay at the same spot, but he went from 3 to 7 feet. We know that he traveled 4 total feet. And on the graph, we can show this as going from 3 feet all the way up to 7 feet. Okay, it's shown as the red line there. All right, now this did not occur in an instant. It took some time. So this occurred from 4 to 9 minutes, which occurred in 5 minutes. Okay, oops, there we go, 5 minutes. I'm going to show us on the graph as well that from, 4 to 9 minutes could be shown there. Okay, and that is a total of 5 minutes. And I didn't write it down, but we also have 4 feet. Okay, we can use this now to express the slope. What we know is that he went, if you look at really what's shown here, that Grandpa George went 4 feet in 5 minutes. Okay, 4 feet in 5 minutes. And that right there represents the rate of change. We know that he went 4 feet in a total of 5 minutes. Now, if you think about how the heck did I get that? How the heck did I get 4 feet in 5 minutes? What I did here is take a look at the picture, is I took the feet, okay, and I subtracted 7 minus 3 feet to give me 4. For the minutes, I took my 2 minutes, 9 and 4, and subtracted them. So I took 9 minus 4 minutes to give me 5, and that gave me 4 feet every 5 minutes. If you take a look at what am I doing here, well, take a look at my 2 points. 7 and 3, what are those? Well, 7 here is my y value, 3 is the y value here. So to find the y value, or the 4 feet, what I did is I just simply took the change in y. I subtracted the 2 values, a change in y, and to find the minutes, I just simply took the change in x. Oopsies, not chong, but change in x. And this is exactly what rate of change is. Okay, rate of change, I'll write this, rate of change is equal to this right up here, my change in y over my change in x. Now, if we look back at the line, again, we're looking at graphically with this equation of a line. The rate of change also describes the slope. I know that when I went from this point to this point, I went up 4 and right 5. Well, notice if I track that up 4, right 5, it takes me from one point to the next point. And this is exactly what how we describe the slope. The slope is the same thing as rate of change. The slope is your change in y over your change in x. Okay, there's a couple ways I'm going to tell you this. The most common way you'll probably hear this is a change in y. Notice how this is how much the line rises, how much we rise to get from one point to the other. So this is known as the rise, and the change in x is called the run. It's how much we had to move forward from one point to the next. So that's called the rise and the run. So you're going to see me use this a lot for slope, rise over run. But I'm also going to give you another equation. I know I'm having you write down a lot here, but my slope, which we're going to label as m, I didn't explain it here, but our slope we're just going to give a symbol as m. Why don't we use s? Well, s is used at other times, so we're going to use m. The way we did this, if we look very back at the beginning, when I give you 2 points like this, to find the slope, all I did is I took the difference between the y's. So I took y2 minus y1. What do these 2 and 1 mean? Well, 2 and 1 simply represent my 2 different y values. And I divided that by my difference of my x's, x2 minus x1. And this right here is known as the slope formula. This allows you to find the slope between any 2 points. Okay, so rate of change and slope describe the same thing. They describe how one variable changes in relation to the other. All right, so very good. So now we're going to apply this. Let's see if we can take the same idea and now find the slope between any 2 points. Now notice here I'm giving you some bigger numbers because I don't want you to be able to plot these points and try and find the slope, but instead I want you to use the slope formula. So slope formula you can see up here, remember the slope is the rise over the run. So to find the slope, I'm simply going to take the difference of the y's versus the difference of the x's. Now I notice I have 2 points. What are my y values? My y values are 16 and 4. I'm going to label this one as y1, label this one as y2. So when I subtract them, I'm going to do y2 minus y1. y2 is going to give me 4, y1 is going to give me 16. So I have 4 minus 16 I'm going to divide that by the difference of the x's. So this is an x and this is an x. Now the key thing here is that if I label this y1, I'm going to label this x1 and that x2 because that's going to be my first and second x. Now the key thing here is when I subtract, it's always x2 minus x1. So if I started with, whoopsie daisies, I didn't mean to do that. But nevertheless, if I start with this y value, I'm going to start with this x value. So I'm going to start with negative 20 minus 12. And now I'm going to simplify. So to simplify, remember we are taking this 4 minus 16 divided by this. So I'm going to start up top and do 4 minus 16. So we have to be careful with our positives and negatives. 4 minus 16, 4 take away 16 is going to give me negative 12. I'm going to divide that by negative 20 minus 12. So I'm subtracting from a negative. That means I'm going to have to change that to an addition and subtract. Sorry, in a negative. I can't talk today, kiddies. And that's going to give me negative 32. All right, now what you're left with is a fraction. You cannot take and divide 12 by 32. So we're going to try and simplify this as a fraction. So I'm going to first notice that I have two negative symbols. So I'm going to notice that when I have two negatives, that those are going to turn into positives. And what I'm going to do is I'm going to take and simplify 12 over 32. So 12 over 32 can both be divided by 4. So 4 goes into 12 3 times. 4 goes into 32 8 times. So what that's going to reduce down to is 3 over 8. And that right there is my slope. And my slope I want to leave as a fraction, and I'll explain why in just a little bit. Okay, now next one I have 21, negative 10, and 7, 24 of my 2 points. Now one question I have for you guys is, does it matter which point I start with? Notice here I started with this point. Or sorry, this one. I said this was my x1, this was my x2, and when I subtracted I started here. Just for funsies, I'm going to switch, and now I'm going to take the other point. I'm going to say, okay, this is my x2, and this is my y2, this is my x1, and this is my y1. Does it make a difference the order in which I subtract these? So to find a slope, I'm going to take and subtract x2 minus x1. So I'm going to take 21 minus 7. Those are my two x values, and I'm going to divide that by the difference between my two y values, negative 10 minus 24. I'm going to then simplify the top. 21 minus 7 is 14. I'm going to then simplify the bottom. Well, I have negative 10 minus, so I'm going to change that to addition and then change 24 to a negative. That's going to give me minus 34. Then I'm going to look to simplify. I have a positive divided by a negative, so I know my final answer is going to be negative. And then 14 over 34, what can I simplify that down to? Well, I know right away I can simplify that by dividing each by 2. That's going to give me 7, and that's going to give me 17. Okay, so that's going to give me negative 7 over 17. And can I simplify that? No. Or anymore? No, sorry. I'm going to get negative 7 over 17. So that represents my slope. Now, just to show you, I'll do this quickly. I'm going to do it the other way. Okay, I'm going to take and I'm going to subtract. Instead of doing it the order I did, I'm going to start with this value first. I'm going to go 7 minus 21. I'm just going to flip the order. So I'm going to say my slope is going to equal 7 minus 21 over 24 minus negative 10. Let's see if I get a different answer. Well, 7 minus 21, that's going to give me negative 14 since 21 is greater. And then 24 minus negative 10, remember when I subtract, I can change that to an addition, change the sign after, and that's going to give me positive 34. And that's still going to give me negative 7 over 17. So notice, the order doesn't really make a difference of which one I start with. But whatever one I start with, if I start with this as my y2, I have to use this as my x2. If I started with this y, I have to start with that x. So which one I start with doesn't make a difference, but when you actually plug it into the formula, it does make a difference. All right, next one, let's see how we figure out slope from a table. Now remember, slope represents the rise over the run. So I'm going to show you a shortcut way that works sometimes, but sometimes there's a different way in which you can do it. So again, when I look at the slope, remember that the slope m is simply your change in y over your change in x. So watch this. Notice if I have a table, I have my y and my x shown. So if I look at my y values, what's the change? What does that mean? Well, it shows how do I get from one y value to the next? How do I get from 3 to 7 to 11 to 15 to 9? Well, if I go from 3 to 7, that means I add 4. If I go from 7 to 11, I add 4. If I go from 11 to 15, I add 4. Notice we talked about before that there's a pattern. 0 to 1, I'd add 1. 1 to 2, I'd add 1. 2 to 3, I'd add 1. Oh my God, I can see a pattern here. All right, so what is my rate of change? Well, my change in y is represented by 4. I know that it went plus 4 every time. And my change in x, I know that it went plus 1 every time. So I know that my slope is 4 over 1. And there we go. So I can easily find it from a table. If that confuses you, what you can do if you are given a table is you can just simply cover up some of these values and pick any 2 points, because the slope formula allows us to find a slope between any 2 points. All right, next example. Let's take a look here. Let's do the same thing. So first of all, can we recognize a pattern? So I go from 22 to 17. What did I do there? I went minus 5. 17 to 12, minus 5. 12 to 7, minus 5. Boom, we see a pattern. Negative 2 to 1. What did I do there? Negative 2 all the way to 1. Oh, that's plus 3. 1 to 4, that's plus 3. 4 to 7, plus 3. So my slope is going to be my change in y, which is negative 5, over my change in x, which is positive 3, which I can rewrite as negative 5 over 3. Bada bing, bada boom. Notice I'm always writing my slope as a fraction. We'll talk about that when we actually get to graphing. Now this last example, this recognizing a pattern works most of the time. However, let's take a look at this example. If I look at my change in y, my change in x, first I'm going to start with my change in y. I go from 6 to 12. Well, that's plus 6, right? Then I go from 12 to 17. Well, that is plus 5. So I go from plus 6 to plus 5. And then my x values, I went from negative 8 to 4. That's plus 12. And here is plus 10. So notice that there's not a pattern. Well, if there's not a pattern, that doesn't necessarily mean there's no slope. But what I'm doing is, if you look at my x and y values, especially my x values, it's not consistent. Notice how this one went, 2 to 1 to 4 to 7, went up 3 every time. But this one's going up 12, then up 10. It's changing. It's different. So if you get a table like this, in order to find a slope, you must pick any 2 points. Now, does it matter which 2 points? No. I'm going to pick 2 points. I'm going to just pick the first two. Negative 8, 6, and 4, 12. Okay, and I'm going to use the slope formula. My slope equals my y2 minus y1 over x2 minus x1. So where do I get these from the table? Well, my y2 is going to be my second y value, so 12. Minus 6 is my other y value. Then if I started at 12, I'm going to start at 4. And I'm going to do 4 minus negative 8. Okay, what's that going to give me? Well, 12 minus 6, that's going to give me 6. 4 minus negative 8, I'm going to add those. That's going to give me 12. And that's going to give me simplified. I can divide by 6 to give me 1, and 2 is going to give me 1/2. And I'm going to leave that as a fraction. So my slope there is 1 over 2. So with a table, be able to figure it out by either picking 2 points or recognizing the pattern. All right, now, with these types of problems, I want you to be able to do a couple things. I want you to be able to understand the slope not only by giving 2 points numerically and be given it from a table, but I also want you to be able to recognize slope and rate of change through problems. Okay? So here we have 2 word problems, and to recognize slope, you're going to have to look for kind of some key words. Some key words you'll see are per and every. If you remember back a long time ago, per is a word we use for division, and it's the same thing for every. So the first one we have, Bob has 40 Skittles. He has 40 total Skittles. It says he eats 5 Skittles every 3 minutes. Okay, so we're comparing 2 things. We're comparing Skittles and minutes. Now, which one represents the rate of change or slope? Well, if you think about it, it says Bob is eating 5 Skittles every 3 minutes. That represents right there the rate of change. It's 5 Skittles. It's tough to spell. Sorry about my writing there. Over 3 minutes. So what's his rate of change? What's the slope? It's 5 over 3. So be able to understand that from a word problem. Sarah then runs, next one, Sarah runs 3 miles every 24 minutes. She has already run 5 miles. So which one represents the slope or the rate of change? So we can see that she runs 3 miles every 24 minutes. That right there represents the rate of change. So we know her slope, or the rate of change, is 3 miles every 24 minutes. So my slope is going to be 3 over 24, which last thing we're going to do is check to see if we can simplify. 3 goes into itself once and into 24 8 times, so I know the slope is going to be 1 over 8. What does that mean? She runs 1 mile every 8 minutes. Okay, so we looked at finding slope through word problems through some verbal expressions. All right, so the next thing we're going to look at is how do we recognize slope through an equation. So here slope is always going to be paired up with the x value, okay, or it's going to be paired up with the x variable, I should say. So if we look at this equation, I have, for example, y equals 3/4 x plus 1. So I have two numbers here, 3 over 4 and then 1. So to recognize which one's the slope, I'm going to look at which one's paired with the x. So 3 over 4 is the one that's paired with the x. So that means in this equation, the slope of this line is represented by 3 over 4. Simple as that. The next one, I have y equals 2 minus 2 over 5x. So which one is paired up with the x? Well, notice I have 2 over 5, or 2/5. But you got to be careful with this. Sign does make a difference. I have to notice that this negative is also along with the 2/5. So not only is my slope 2/5, but my slope is negative 2/5. Okay, so that's the one that's paired with the x. So pretty simple to recognize which one comes from an equation. The last thing is to recognize how do we determine slope from a graph. So remember this one, we're going to use the idea that slope is rise over run. Slope describes how much I move up or down or left and right. Now, reading a graph, we're going to read a graph just like we would read a book. Okay? We always read a graph from left to right. Okay? Why do we do that? Because if you think about this point here, remember this point being as the origin. The origin represents 0. So when I count, I naturally count up from 0. I go 0, 1, 2, 3, 4. So it makes sense to describe things in an increasing fashion, so from left to right. So from left to right, I'm going to look at the slope. I'm going to look at between any 2 points. So I'm going to start with the first point. I'll start with this one right here. I'm going to ask myself, how do I get from this point to the next point? Yeah, I could follow the line, but remember the slope describes how much the line moves up and down as compared to what it does left and right. So I'm going to start at this point, and I'm going to go up and down first. Well, I notice that I do not have to go up, but I have to go down, and then I have to go right. Okay? So I know I had to go down, then go right. Now, how much did I go down? Well, I went down 2. Now, I'm going to label that as minus 2 because the thing is going down. It's decreasing. That's a 2. That looks like a 3, I'm sorry. And then it went right 4. So what is my slope? Well, my slope is going to be negative 2 over 4. Now lastly, what can I do there is I can simplify this to a 1 and a 2 by dividing both by 2, and that means my slope is going to be negative 1 over 2. That means overall it goes down 1, right 2. Now here's the interesting thing about lines, is that this pattern continues on and on and on. Now watch this. I'll show this in blue. I'll show it in purple. From this point, notice I can go down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. And notice that every time I follow that pattern, down 1, right 2, down 1, right 2, that I'm always going to hit a point on the line. Okay? So the key word I'm going to fit with this is the slope of any given line is always constant. Constant means that it's the same. It's constant. Okay, next one I have a line now that's going up and to the right. So again, I don't have necessarily points shown here, so let's first clearly identify some points. So first point I can see, I'm going to choose one there. Okay, now does it matter what other point I choose? No, because what's going to end up happening is I can simplify. So I'm going to try and find another point. Now, I'll try and find one further away. I'll go right here. I did this on purpose. You may find some other points. Go ahead if you found other points. Try and figure out the slope a different way. But given those 2 points, I'm going to try and find how much it goes up and to the right based off of that. So I know that it rises all the way up to here, and the run is that. Now, I kind of hurt myself because I'm going to have to count all these. So bear with me. Going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whoa. So my slope wind had a rise of 12 and a run of 3. So now to simplify that, what's 12 divided by 3, or 12 over 3? Divide each by 4. That's going to give me, divide each by 3. It's going to give me 4 and 1. That means my slope is positive 4 over 1. And again, to show you what this means, some of you may have recognized, why the heck did I skip a point? I could have went here to here, up 4 over 1. I could went up 4 over 1, and I could have went up 4 over 1. It's the same pattern because slope is always the same. So this is identifying slope graphically. All right, last slide here, almost done, kiddies. I know this is a longer one, but this is a very important concept. Now, when we look at slope, you should notice that lines can do a couple things, right? We saw in the last example that lines can go up and to the right, can go down and to the right, and all that. So there's really 4 different ways in which we can define slope, okay? And we're going to use 4 different words. Notice that when we read these things, we're always going to go from left to right. So we're always going to read them from left to right. So notice this one, from left to right. If I were to look at any 2 points on this line, say between here and between here, that this thing goes down and to the right. The way we describe a slope that goes down and to the right, or that goes down, is a negative slope. So this slope is said to be negative. To be able to identify a negative slope. This one over here, notice how from this point to, let's say, this point, that it goes up and to the right. So going up and to the right, this is an increasing value, or what's known as a positive slope. Okay? The next 2 are kind of tricky. This first one, if I go from one point to, say, another point, well, let's think about the slope. I go up, I don't go up and down. So my rise is 0, and my run is whatever value I want it to be. Say, in this case, my run is 3. Well, what's 0 over 3? That's 0. So this run right here has a slope of 0. And if you think of what that means, it has no slope. Imagine going skiing on this slope. That'd be like putting on your skates and standing on the floor. It'd be a very fun ride. In this case, you wouldn't move. There would be no slope because the slope is 0. And the last one here, we are going from one point to another point. Well, let's say I choose those 2 points. I go up 1, 2, 3, 4. I go up 4, but now I go right or left 0. Oh, now I'm dividing by 0. Well, think about this. I'm going to give you a candy bar, let's say a Snickers bar, and I want you to divide it into 0 parts. So you're going to divide it into 0. Wait, that doesn't make any sense, right? So this tells you that this slope, the word we're going to fit here is called undefined. That the slope here is going to be undefined. It doesn't have any slope. It does have such a steep slope that we just can't define it. So the word we use is undefined. So be able to identify whether a slope is negative, positive, 0, or undefined. So we had a lot of things dealing with slope. How to calculate slope numerically, how to recognize slope verbally, how to recognize it through an equation, how to graph slope. A lot of stuff dealing with slope and rate of change. One of the big ideas we're going to talk about. I know this was a little longer, so I apologize. So if you had any questions, any confusion, make sure you bring it to class. All right, kiddies, we'll see you. Good luck on the practice. Peace out.